Welcome, Gerhard. Thanks so much for coming. Could you please say a few words about yourself?
Yes, my name is Gerhard Jöchtl. I'm Head of Department Information Technologies and Digitalization of Salzburg University of Applied Sciences, and I'm glad to be here.
Thank you so much. So our first question is, I think you work with digital signal processing. My first question is, what do you think would be important for students to know after they've graduated about digital signal processing?
Yeah, I think it's important to know the basics so that you cannot do that you cannot make a big fault when you use that. So you find, for example, a lot of filter types and all these things, and you should have a rough idea which type of filter maybe you should use for a specific problem. So we have two groups of filters, for example, FRR filters, IR filters. FR filters are filters with linear phase, which means all frequency components are delayed by the same delay. So this might be useful for some applications. If we need, for example, very steep filters, we can use these Butterworth, Chebyshev, elliptic types of filters. They are very steep, but have the disadvantages that the phases are very non-linear, and you might even have not a stable amplification, which is called ripple. So you have to take care of this field. So if you use filter, for example, you have a noisy signal from a sensor, just do not take any filter, just think about what filter do you need for these applications. Do I have to have a linear phase, or can I accept ripple and something like that, and then decide to use the right filter.
Okay, yeah, sounds great. Then next question is, are there any tools that you use regularly for DSP, or that you might recommend that it would be good for a student to know about?
Yeah, I by myself use MATLAB because this is a standard software.
Yeah.
Unfortunately, it's expensive, and
yeah.
you will not always have access to it. So Python is also a very good
yeah.
way.
Yeah.
So they also have more or less all the features, also what MATLAB offers. So
yeah.
this is quite a good choice. And the good thing is also that even very complex algorithm at the end can be reduced to simple for loops. So it's
yeah.
just a multiplication and addition at the end. So if you make a Fourier transform or a digital filter, is just a convolution, which is nothing else than a for loop
yeah.
and whatever. So
yeah.
at the end, signal processing is quite simple to implement. The problem is to find the right algorithm for that problem.
Okay, yeah, great, thank you. Then a third question. In this course, the students have to do a project with little robots that have various sensors connected that can be quite noisy or cheap. Maybe they have cameras that are distorted. They have ultrasonic sensors, encoders, and infrared sensors. Do you have any recommendations about how they could use DSP in their projects?
Yeah, there are a lot of possibilities. So to really answer the question, one should really know the concrete problem.
Yes.
As I've said, there are a lot of possibilities to filter away distortions,
yeah.
take care of which filter you use, even 2D filters. So for example, image processing mainly uses FR filters, otherwise the picture may be distorted. There are also some other possibilities, image adaptation.
Yeah.
So especially with pictures, it's quite important that you use the different light.
Yeah.
So if it's too dark, it might get bad. And so before you adapt the filter to these things, make sure that the light of the picture is adapted in the right way, so that you have not a saturation or whatever. Then maybe use a filter, two-dimensional filter, and then there are a lot of also other ways. So really I cannot answer if I do not have the concrete problem.
So I think you're maybe working sometimes with adaptive filters. Can you tell me a little bit about that? When you might want to use one of those?
So this is a very big advantage compared to analog filters. So digital filters, you can use adaptive filters, which means that the filter adapts to the noise. So think about a scenario where you have, for example, an interview in front of a waterfall. It's very noisy. The problem is the waterfall this noise consists of all frequencies, the complete frequency spectrum, and also your speech lies in this spectrum. And the problem is, how can we get rid of this noise?
Yes.
And this adaptive filter measure the noise separately with a second microphone.
Mm-hmm.
And if you manage that the noise is given with the same phase and the same amplitude, then you can just subtract the noise.
Yep.
And this could be done, for example, by so-called adaptive filters, where the goal is to adapt the filter parameters statistically so they can get rid of this noise. It's a quite interesting problem. And this is also the main idea of this adaptive filter is the same what is used for neural networks, just a learning strategy.
Right. And I guess also in image processing we have adaptive background subtraction and stuff like that. So it's really useful. Thanks so much, Gerhard.
Thank you.